What's up guys, welcome back to another YouTube video. I hope you're having a great day and a great week. So if you're new to the channel, go there and smash the subscribe button. It's gonna be so good. So if you're watching this video without watching my first part of my math video, then it's gonna be hard to understand. So just pause this video, go to my first video, and then you can watch this. It's gonna be so good, interesting, so stick around and let's have some fun in math. So, before we go into the examples, let's just recall what polygons are. Polygons are nothing but an enclosed geometrical figure which are made up of 3 or more line segments or sides. So, this, I'm pretty sure you could see what this is. This is just a random figure which I drew with only line segments and which is enclosed. So this is considered as a polygon. So there are many different types of polygons. There is this quadrilateral, triangle, pentagon, hexagon. So this is a square, which is a quadrilateral because quad is nothing but 4. So it's made up of 4 line segments. And this is a triangle, and this is a pentagon, if I'm not wrong. But this is circle, but circle is an enclosed shape, but it's not made up of line segments or sides because all the boundaries, there's no endpoint. So this is not considered as a polygon. Now let's see some examples in polygons. Let's just forget that. So examples of polygons means they're only in most exams, as I know, or in which I wrote, they give only examples such as classify this polygon as, they give something like, let's say this is a triangle and they give this and they say classify the polygon, and then the students just write triangle A, B, and C. So that's just the easy part, and we don't really need a bigger explanation. So, but most people most people who have a problem is they give the name and they draw the figure. So that's just the hard part for the students. Now, I got 2 problems over here. It says octagon QRSTUVW and hexagon FEDCBA. So first, let's look at this problem. Octagon. If you do recall, octagon is an 8-sided figure. So let's see. First step for every student, it's just simple. Just first draw the figure. So octagon means 8. So this is an octagon. It's not really in an accurate position, but that's how an octagon looks. And coming to the naming, so I'm taking the point somewhere over here and I'm starting with Q. And now comes the trick. You just need to go in one direction. You can't just go Q, R, S, T like that. So Q, and this over here is R, and this one is S. T, U, V, W. Okay, I think I messed up. Or yeah, we do have one more point. That's how it's gonna come. So Q, R, S, T, U, V, W, X. I forgot to write the X. So this is how it's gonna look. So you just need to go in one direction. You just don't go in different directions. Either you go this side or this side, like clockwise or anti-clockwise. That's it. Now let's go to the hexagon. Nothing much explanation needed. Hexagon means a 6-sided figure, so that's 6 sides. So F, E, G, C, B, and A. It's basically A, B, C, D, E, F. So yeah, that's how it's gonna work. Now, let's recall what parallelograms are, and let's do some discuss about the parallelograms. So parallelograms are nothing but quadrilaterals in which the opposite sides are congruent, which means the opposite sides are equal, and the opposite sides are parallel, which means they don't touch each other at all, and the opposite interior angles are equal. So this angle and this angle are equal, so are this angle and this angle. Now, let's see an example of this point. This is the kind of important. So it says consecutive angles are supplementary. I did an example over here, so let's see. So if it said that angle A, is 110 degrees, and the paper says to find angle B, C, and D. So there are actually two ways to do this problem, and one is kind of a long long procedure, and the second one is kind of the easy way. So first, let's take a look on the long step way. So as angle A and B are consecutive, they are supplementary. That means they are equal to 180 degrees, and complementary means they're equal to 90 degrees. So 110 plus angle B is 180, and if you subtract 110 on both sides, you get B is 70. So B is 70 degrees. So you do angle C and D in the same way also. In the same way, just 70 plus angle C is 180, and you get angle C is 110, and 110 plus angle D is 180, you get 70. So if you observe closely, look at this. According to the third point, opposite interior angles are equal, 110, 110, 70, and 70. So now the short way is basically you just find out angle B, and then you get all the other two angles easily. 70. So this angle is 70 because the opposite angles are equal, and this is 110 because that's 110. Easy. So now as we discuss the examples of both polygons and parallelograms, now let's go into a new topic. So I'm not coming in front of the camera because there's no space. So before I show the diagrams, so first let's talk about the special parallelograms. So there are three special parallelograms. One is a rectangle, and it's a parallelogram with 4 right angles. And there's a rhombus. It's a parallelogram with 4 congruent sides, and a square is a parallelogram with 4 right angles and 4 congruent sides. So these three parallelograms have special properties, and all these properties are also in the parallelogram. So now let's look at in detail and draw the figure, and let's see. So this is a square. Duh. So I'll have right angles. I'm sorry, those are not exactly right. So all the right angles and all sides are congruent. No, yeah, yes, all sides are congruent. In a rectangle, all sides are right. Only all sides are right angles. And in a rhombus, all sides are congruent and all angles are right. I'm sorry, for rectangle. So from this you can actually see that the properties of rectangle plus the properties of rhombus actually equals to the properties of the square. So if you want to know how you remember it, it's just remember the properties of square, and then you could divide it. The angles are rectangle and the sides are rhombus. Sorry, these do not indicate that they're equal. I'm done. Let's just so equal and yeah. So as we discussed about what these special parallelograms are, in the next video, let's check out some examples.